sure if it's recording. I use Linux, and the client is well, it's not the same as in Windows. So yeah, okay, recording has started. So good morning, everyone in Brazil. I think good afternoon. So people somewhere else, or maybe good night, good evening. Today I'll be talking about condition monitoring challenges for the offshore wind energy in Brazil. Before starting with the presentation, just some forward. I am a mechanical engineer, and I did my doctorate at ITA, and a doctor in engineering, not a PhD, right? But I have a strong aerospace background. I started working in the field 26 or 27 years ago at Aeromot. It was a small company in Porto Alegre. And I have experience at Brazilian Institute of Aerospace, uh, Aeronautics and Space, so aerospace and some consulting in the field. I'm professor at the Federal University of Santa Maria since 2015, 80 years already. And okay, so I've been doing research in some of these fields here: flight loads, optimization, aeroelasticity. I've been using OpenFont for the last 2 years and OpenFast for like 5 years at least. But this presentation mostly was done because of my cooperation with the group of Professor Humberto Pinheiro. He's a professor, he belongs to the GEPOC, it's Electronic and Power Control Group at Federal University of Santa Maria. And some of the works that I'll show here, I think most was done with in cooperation with the engineers Glebmi Hübner, Leonardo Diaz, and Ricardo Morim. Okay, so I think it's important to mention that beforehand. Okay, so this is the outline of my presentation. I'll give some introduction about the topic. What is condition monitoring itself? Just to make sure that you understand, or people that are not used with that, it's not the traditional maintenance strategy. We'll discuss some of the sensors that we need to accomplish the condition monitoring. Next, we're following the process, right? So next, we need to talk about the data management. It's not only signal processing. We have to discuss how we process, where do we process the data, where do we send it, when do we send it, and so on. And actually, okay, so the last step is the automatic fault detection. There are lots of papers, work going on, okay, and concluding remarks. And then next we talk about the workshop. All right. So the introduction here is an important thing. What is condition monitoring, right? That's a question people that is not used to the topic may ask. So which condition are you monitoring? How to monitor that? And once we are monitoring, what are we expecting to see? A green light, a red light, or a text explain what's going on? And then next, what to do with the information? Okay, something is wrong. What should they do with that? Okay, so these are questions very important for the condition monitoring system, and let's see if we can access all of them. Okay, so before going there, what to monitor, right? An overview of our specific problem. We could do condition monitoring of anything, for example, our car, or even our house. It's what's going on right now. We can monitor everything in our house, or our cars are becoming more and more intelligent. But here, we need to talk about wind turbines, right? So the machine that we are monitoring are wind turbines. And this monitoring is related with maintenance strategy, okay? We need to reduce costs. We see that very soon. Things began with structural health, or at least we could say about the gearboxes, because people are used to monitor gearboxes for a long time already. And important thing here is that it's a harsh environment, right? If you think about offshore wind energy, offshore wind turbines, things get worse. And then everything is balancing, it's rocking, okay? So there's a tower that is flexible, the blades are flexible, so everything is moving around. And we have moist, we have rain, we have thunderstorms, we have haze, lots of things going on. But while it's working, we need to maintain the energy production. That's the most important thing, right? We have to maintain the aerodynamic efficiency. We have to take care of electric faults. Are we transmitting? We're not transmitting. What's going on? And also, I'd like to mention this work. I try to bring for this presentation lots of recent works, right? So in this work of 2019, there's this number of 20K offshore wind turbines reaching their end of service life between 2030 and 2040. So that's a question. Can we extend production also? How are these things? How are these turbines behaving during this year, during the 20s, during the end of their lives? Are they healthy? What should we do to instead of just sending them to the trash, okay, send them to recycling, can we keep them producing? Here in this slide, I tried to bring some of keywords that you might find in papers or works in this field. Most of them I took from this work from 2014. You see, it's 8 years ago. It was a state-of-art review at that time. And things that I think that most important thing here is, of course, the people that are investing in the wind farm, they want some return of their investment, right? So we need to reduce cost of energy. We have to have reliability on the operations. So we need operation maintenance system. We need people dealing with that. We need to detect faults. We need to have a good maintenance strategy. And so things come to the condition monitoring system. So this is a way of reducing cost of energy, increase return on investments, and okay, so these two green blocks here, they are related to what I am trying to introduce to you. Okay. Now next, what's the operation cycle of wind turbine? I'm looking only at the machine. Here next we can extend this cycle. So the machine is operating. It's there's a lot of physical response going on there. Okay, yeah. Just look at the Sarah message on the chat. Okay, so come again. We are acquiring lots of data from this machine, like power, current, the accelerations, the strain, temperature, lots of things going on. Okay, this data is our time series data. We need to process it. So yellow boxes here, this is the thing now, right? We need to do some diagnosis and prognosis. Okay, we need to do that to then decide about maintenance and decide about control. So this is a cycle that I am introducing control because most of people just talk only about maintenance, but I think about control too. And at the end of the presentation, we talk a little bit more about that. Oh, next step. So, okay, this is a picture I took at the Cerro Chato wind farm in the south of Brazil, next to the border with Uruguay. It's almost Uruguay here. So what do we have? We have machines, okay, going on. We have machines together. We have the wind farm. There is a supervisory system somewhere. In this case, the supervisory system is at the city. One of the systems The initial is at the city of Livramento. And of course, this is the goal. We need to send energy, okay, to the transmission lines. Next, okay, things are really simple here, right? But then when we talk about a prognostic health monitor or prognostic health management, so this is a picture from this work of 2014 also. You see, 8 years ago, you can find this document. I think someone is with the microphone open. Okay, so one thing that I have to say about this diagram, it's a complex system. I don't know if you agree with me. If the figure is good for you there, you see SCADA data, we see decision making, stress analysis, we have blade loads, we have historic operation conditions, turbine fault diagnosis. Oh, okay, there are lots of boxes here. There are lots of arrows and pointing everywhere. It is a complex system, right? And then we see that this is a very complex topic because we're trying to gather lots of information, lots of science and engineering together. Okay, we have some standards already, and I recommend people to take a look at that before going further. This condition monitoring diagnostics of machines, it's a general thing. It's not only applied to wind turbines, but then we can find something about wind turbines specifically at ISO, okay? And, okay, so what kind of maintenance do we have? The traditional, the corrective. So there's this expression, breakdown maintenance. Okay, what is that? It's run to failure. You just let the machine run, operate, and then it breaks at some time, and then you change gear, you change some parts that need to be changed. I don't know. So what happens is that mostly of the times it's an unexpected stop, right? You are not, perhaps you are hearing some vibration. If there's a experienced operator, it will notice. It's an experienced pilot. It say, okay, this airplane is going to fall down right in a minute. But if you're not, it's unexpected. Another kind of maintenance that we have is preventive maintenance. So it's that's what we find mostly in Brazilian industry, and I believe in all world industry, you still have this. It's time-based. Okay, you say, all right, perhaps it's machine operation based, like airplanes. You take 100 hours of flight, 200 hours, 500 hours, 1K hours, and then you stop your aircraft to do some different levels of maintenance. Let's check the oil and so on. Or we can have schedule stops based on months of operation, for example. This is mostly based on fault storage. So if you have already worked at the chão de fábrica, like say in Brazil, it's in the industry floor, you know that you need to rearrange it. So you have to keep discussing. Then there are some machines there that some CNCs that are breaking every other month, so we need to change that. But what happens is that maybe the maintenance will be too early. We change oil and the oil is good, or too late. Oh, it breaks. The machine breaks before the next maintenance. And what's going on now is the predictive maintenance. So we can, in this case, we need to forecast faults. It's a condition-based maintenance, so we need to know the condition. Somehow we need to know what is the condition of the machine. And the goals of this predictive maintenance is to detect, diagnose, and forecast. Okay. Also in this work, you see, it's 2004. It's almost 20 years ago. You can also have the proactive maintenance that then you design to avoid maintenance or to ensure that your maintenance will be very short. You stop to, you are not stopping your machine at all, perhaps, or whatever. Okay, so we can evolve from corrective, the old style, to maybe something more intelligent, right? Some bibliography backgrounds, just to show you that this is not a new topic. You have this BB, it's an Australian engineer, book from 1988, and in 2004 he wrote a book about monitoring of pumps, very important machine that can find in, for example, in chemical industry or oil and gas industry. We don't have much in the wind energy operation, except the big pump, or let's say that. Okay, so commercial aircraft, to have this work from Boller and lots of work from the end of 90 decade. So we are monitoring main spar, wing fuselage structure. Then we moved on to flight controls of aircraft. And so you find lots of works. This is very interesting here from Neiman et al. He is now a professor at Michigan University. And it was actually, this book here was a workshop that happened at Foz do Iguaçu in 2004 with lots of Brazilian engineers and professors. Some definitions here is just keywords again. So faults and failure, we need to identify faults and failure. They might be mechanical. For example, something broke, a gear broke, unbalancing. We talk about that later. Cracks on the blades. We saw some presentation about that. Electrical faults. Okay, the inverter is not working. Transmission faults. So there was a tower fell down somewhere. Hydraulics faults, for example, pitch and yaw are not working. We need sensors. Okay. We need data engineering, we need to transmit, and we talk about sensors soon, and we need algorithms. So these three parts we talk next. So, all right, so about sensors. We need to define sensors. Sensors are mostly transducers, transducer device that transform some physical variable into a electrical signal, or electrical, we mean very soon, even if the transducer itself will transform it into digital signal, 0 and 1, that's it. But then to define which sensors, we need to define first, what are the faults that might happen? Lots of faults, right? But then we need to define, what are the risks of this fault? So if there's a crack, the tip of the blade, what might happen there? Otherwise, if there's a crack at the root of the blade, what might happen is this crack increases. Or at the tip of the tower, I don't know. So what are the consequences of these faults that we might have? And I suggest that there must be somewhere or sometime during the design of the turbine a FIMEA analysis, okay, a FIMEA process. Lots of people gather together in a room for 2 or 3 days discussing everything that might happen. At least that's what we do in aerospace. So we gather specialists of all the fields that are working on the design of the aircraft or the rocket or the satellite, and try to discuss, okay, what might happen that this thing stopped working after 1 month of operation or after 1 week of operation. Here, for example, I was there. I didn't put any picture here because I don't know if it could. But for example, there was a big storm in 2015, December of 2015, at the site in the border of Brazil, and lots of turbines that were being assembled just fell down before even operation. Okay, they were there. They were waiting for certification and start of operation, then didn't even start working. I saw that and have pictures of those things on the ground. Okay. Then, okay, what are the faults and what need we measure to identify these faults? Which parameters will indicate critical faults? That's a problem. And how critical is the fault? Again, are we have a few sensors? Can we identify critical faults? Though we have parts and systems, we need to identify fail modes for each of these parts and systems. We need to identify which physical response might have, and then we need to start doing the sensor reading. Define sensor, specify sensor, then start reading. Okay. Here is the machine. Oh, I forgot to put the numbers around here, but I think that you can do, you know where parts are already. So blades, pitch system, if you come from where the wind hits the machine and things start moving, so we look at the blades. There's a pitch system here inside of the rotor. We have a main shaft. Of course, this shaft is supported by bearings. There's a gearbox somewhere here, and that is even if, well, maybe not if it's a direct drive. We have the generator. We have a power control somewhere here inside, electronic parts. We have yaw system, turning this rotor, the nacelle around. There's a tower. There's a foundation down below. There's a floating foundation or whatever you might have on your offshore park. And after that, we have the transmission. Okay, so I counted here 13 systems, we might call systems that need to be observed. We can discuss that later, or if you have any question, please just raise your hand. But still, there are a lot of things that we need to observe, because if any of these things fail, we might not only lose power production, you might lose the entire turbine, okay? And of course, then you lose power production overall in the farm. Again, so we can organize all the systems into different kind of sciences or engineering. So we have rotor machines, bearing, gears, motors, for example, for pitch and yaw. Structures, static of dynamics. You have blades. The blades are very flexible. They're made of composite materials. Lots of things going on there. The tower itself, is it the tower? How is the tower assembled? Is it a good quality, and so on? The foundation. I've seen last year on LinkedIn some pictures of a tower that a turbine that fell down entire. So the tower didn't break. Of course, the blades broke after that, but the nacelle was intact. The tower was intact also. It just fell down. What do we might deduce? Okay, the problem was on the foundation. And then we need perhaps to take a look at that also. Okay, then electrical control, electronics. I'm not talking much about this because this is a field that I about inverter, generator. I know something, but I'm not very good at this part. And perhaps we may also have sensor faults, right? That's important because, okay, the sensor is not working anymore. Something happened, and then we have readings, false readings, for example, and so on. An example here of large turbines that we are having now, this a picture of the Haliade 6 megawatt, but we have already Haliade X 12, 13, 14. This one is 150 meters diameter. We are already, this big machine here is already operating. This 220 meters rotor diameter. What you see is a football field blade span. It's very long. Try to run it along it. If you put sensors there will be lots of cables running through the blade. Okay, we might have this guy here is a direct drive. Okay, oh, at least we don't have gearboxes. But then we have larger loads on everything else. Take a look at this shaft. It's immense, right? And then you don't have gearbox, but we have different kind of bearings and all the loads on the blades here. The root loads are immense, and things start to grow. Okay, become larger and larger, and okay, the problem is not that easy again. Now talking about sensors, okay, we need to measure lots of things, right? So here in yellow, or mostly yellow colors, wind velocity, acceleration, displacement, strain, cracks, friction, temperature, current, fire, then which kind of sensors you need. You see that, okay, that's a lot of sensors here, different sensors, and even if these guys here are the same accelerometers, for example, the range of measurement for an accelerometer at the gearbox will be completely different if you need to measure the normal modes of a blade. The first mode of a blade is half hertz, and on a gearbox, or the largest mode that we need to measure on a blade will be less than 20 hertz. Okay, so the first 3 or 4 modes, bending modes. On a gearbox, we might need to measure 10K hertz. Okay, that's a big difference. Same sensors, different measuring ranges. And if we go to the offshore turbines, offshore machines, then mooring tension, water temperature, water conductivity, water depth. Okay, it's increasing, decreasing, what's going on, fire monitoring again here. But then there are other things that we measure. Okay, water, for example, we need to know if how the turbine, how the metallic parts will respond. We need to somehow measure if there's a degradation on the metallic parts and so on. Okay, next slide. So just give you some example of sensors. Okay, it's a lot of information on each slide here, but it'll be available, and I try to bring updated, as I said, updated reference here. Okay, so let's take a look at the rotary machines component. It's a very established process of monitoring these machines. I have this book from 2004, Practical Machinery Vibration Analysis and Predictive Maintenance. It's talking mostly about rotary machines. So it's not new. What's new here? What's new in the wind turbine field is that we have specific rotation, specific problems, and these things need to be addressed with machine learning. Okay, some kind of diagnostic algorithm. So again, there are standards for that, and this one is specifically applied to horizontal axis wind turbine with gearbox. Bearings, you need to observe bearings, because bearings, they are prone to plastic deformation. They need lubricant. They are prone to erosion, even especially if they are working on maritime environment. They might show cracks and fractures, of course, wear out, and then suddenly what happens is that the turbine is not the inertia of the rotor increase. Okay, we are increasing friction on the bearing, everything else increases, and then we have a torque that should not be appearing on the system, a torque that is removing power from the turbine. So it's affected by environment corrosion. Example here of works dealing with normal modes, tower normal modes. Now, this work that I am showing is an example of specific tests done on a machine here. It's not this specific machine. I just got this picture on the internet, but just take a look on how it is. And it's a monopile, hollow monopile. It's on the North Sea, 23 meters sea depth. Okay, so what was it? This was a single turbine being measured with two 3D accelerometers, 8 strain gauges, inclination sensors, grout sensors. This guy here were using 50 hertz, 24 hours measurements. And this is the thing that is going on the research. Lots of, we are trying different kind of methods: statistical, operational model analysis, finite element model validation for a twin, digital twin assembly. And just an important thing here is to take a look at the frequencies that they measured. So the 4F, the first frequency, it's a banding frequency. The other banding frequency is a third of a hertz. Okay, it might be coupling with the 1P frequency of this turbine. Next, the second turbine, or even the fifth mode here, is only 5.7 hertz. It's very low, very low. We can count it if you take a look. If you make a video, we can count it just counting the 10 seconds and counting the vibration. You can see it. Okay, that's interesting. Let me go here. Oh, this another kind of monitoring that is being investigated. This guy here, Nadella, was my colleague at Michigan University. So in 2014, he was, when I was there, he was selling lots of MFC, piezoelectric material, on composite parts and trying to identify, implement methods to correctly identify damage. So there is still work going on there. If you take a look at this site here, you find a database, a open database made from at TU Delft, tests of damaging composites. It's not only for aerospace. It's a project for aircraft maintenance planning, but of course it's a composite wing we have on our wind turbines, right? On this topic later, if you get this presentation, you can take a look at Ragavan and Sesnik. Sesnik was the advisor of Nadella in Michigan University, and lots of other works going on in this field here, because we have a very efficient material, but still we need to improve the techniques to identify. The keyword for this thing here is smart materials, or also Lambda waves through the structure. This is a very recent work. The Fremilev defended his PhD, I think in January or February. I was not able to attend to see it, but still, this is a very interesting work that I want to talk later. It was a work done on a test stand, only the blade, fatigue tests done by Siemens Gamesa in Denmark. What I have here, I took this picture from a paper from 2022. So what you see here, some artificial damage imposed to this blade, and lots of this different sensor position on the blade. And again, what was he trying to do? To identify which was the best thing to use to identify, to monitor fatigue effects and damage increase. So this just a picture here on the bottom right that showing that the PSD signal, the power spectral density, shows the difference between the health and damage state after 2 days of a fatigue test. Okay, so 2 days, it's an accelerated test. Again, let's just take a look at one. detail here, it goes to 3 kilohertz to identify the response, and it's a completely different range of 5 or 10 hertz or even 100 hertz. Okay, Yoshi, now I saw your hand. And okay, so things are different. You want to make a question, Yoshi?
I think Sergio raising his hand.
Sergio, oh, sorry. I cannot see who did that.
Just my beautiful
no,
face,
yeah,
don't
okay.
you see?
Yeah, no, now I see it. Yeah, I am not seeing your face. Sorry.
Well, it's me again.
Yeah, okay, Sergio.
Hi, Carlos.
Now I saw it. Hi.
I would like to just to add a small comment to your talk.
Okay.
There is a group at the Federal University São João del Rei who are working with artificial intelligence for monitoring rotating machines.
Mm-hmm.
And well, in their presentation, they claimed that they can predict when the machine will fail.
Mm-hmm.
So the constant monitoring, they know the patterns and so, and the machine and the computer says this machine will fail in so many hours. Almost like how 2000 in the movie 2001 that says that that component will fail in 24 hours. So and that
Yes.
they are doing that. It's very interesting.
Yeah,
Work
actually,
they're doing.
you know that VEG, the company from Jaraguá do Sul, they are selling a small device that you can put on your industry, and it will connect with a monitoring system, your supervisory system on your factory, and they will say the same. Okay, hot air machine is not a problem. Everyone knows how to do that. There's also these guys from, I don't know if it's Recife, Traction. Have you heard about it? I received lots of advertising from them. They're guys like kids, okay, Sergio, like they are in their 20s. And they're selling this small device that you can just put on top of your gearbox and okay, it's working. What's the problem? Yeah, you can do that on the factory. Everyone is passing around. Oh, okay, the sensor is not telling anything. Just go there. Oh, you take the boy, 15 years old boy. Oh, please go there and take a look at that machine. Oh, is it working? Just okay, just plug it again. Okay, thank you. The coffee boy. See?
Yeah, the coffee boy did that.
Yeah, the coffee boy. Yeah, the guy, our student, 18, 20 years old that started working there. It makes a coffee and then go there, take a look at that sensor. What's the problem here? These turbines will be in the middle of the sea. Okay.
Yes, this is complicated.
Yeah.
You see, this is the I think that the key point is the vibration of the system.
No, not
I would
all.
say that 90% of what you're talking about can be monitored to the changes in the vibration. Even if the mast vibrates, you can separate vibration from
not
that
that
to
much.
that.
Yeah, we talk about that. Okay.
Yes. Just like in helicopters.
Yeah, but this is the problem again. So let's follow here.
Yes, okay.
So the critical faults. So next step. Now we stopped talking about sensors. I gave you some examples. There are a lot of works that you can find. We have companies selling service. Service said. Okay. Next step. So the faults are. We know what the faults you need to follow. The sensors are there. The data is being acquired. What to do next? Okay. Then again, as I said right now, well, the machine is there, like 100 kilometers inside the sea, or it's on the south of Brazil, or it's somewhere in Bahia, Pernambuco. It's very far from your engineering management site. What to do? Okay, so the data is there. So we need to, for example, there's a discussion of we certainly need some initial signal processing. We need some computer inside the machine doing processing. Because, why that? because of data transmission, okay? We need to have some data handling, and there are discussions of that, what to do, and even more, we need to put more computers inside the turbine. And with this data transmission, we may perhaps inform a digital twin. The digital twin, I don't know, I think Eloisa talked about digital twin a few days ago. The digital twin is running in parallel with the farm, with the machine, and then we send data to digital twin, and then you can improve your response. But then there's this guy here, SCADA. I don't know if everyone knows about SCADA, but then this SCADA is informing the data lake. Maybe the digital twin is filling the data lake, and from there we need to have some analytics. Someone, I don't know where, maybe on the other side of the world, doing analytics about the wind farm that is installed, that is running in Brazil. So here's some of this flow, starting with the wind turbine, sensors, pre-processing, transmission, database. They may be on the cloud. This transmission here might be wired or wireless. Okay, so this is the thing. Wireless made things much easier, or 5G cell transmission, for example, cellular transmission, and then analytics, and go to lots of clients. I don't know, the operator, the maintenance teams, the owner of the business, the guy that is making money, and the guy, I don't know, that made the turbine, and perhaps it made an agreement to have some data back to improve their future turbines. I don't know, many clients there. So this is a flow of data, lots of data going on. Some of them are wired, some not, and so some examples here of offshore systems I also brought to you. Okay, 2014, there are new things going on, right? Next, SCADA. SCADA is a supervisory control and data acquisition system. It's a standard in the industry. I read somewhere that's like 95% or even more of the wind farms use SCADA. The goal was to control, monitor, and analyze industrial device and process. So you might not buy it only for wind turbines. You might buy it for your chemical plants, for your oil industry, I don't know, anywhere. But in wind turbine industry, that's the standard. So it's made of software and hardware components. You know how things work. If you want some module, you pay a little bit more. You need a specific software to do some analysis. Okay, yeah, it's cheap. You can add it, and then your basket start growing, right? Just like when you go to Amazon and start, okay, this is fun, I can buy it, and then okay, things start growing. So it's a modular system where you can install new. So it's a remote and on-site gathering of data from industrial equipment. So this is a site here. You may take a look. Recent examples of condition monitoring systems using SCADA. You will find lots of works. Okay, it's not a problem. It's still a problem, but we need to do some research on that. But still, what happens? So Sergio, for example, I don't know if he's still here. I finally found how to look at the list. Okay, so here I put only 4 turbines and maybe a environment tower here, anemometer, temperature, wind velocity, wind direction. So we put 100 more turbines around here, perhaps another tower, another 2 and 3 towers, and you see that there's a lot of data going on. Okay, lots of data. And there must be a communication system network, fiber cables mostly, or you can try something new. There's a wind farm controller, and then SCADA. And SCADA will do some processing, or the SCADA must decide actually, or the operations must decide which data must be passed. Okay, about the size of the data, next slides. Also from here, we need to inform the substation might be automatic grid operator, and these guys might be talking or not. I don't know. They should be talking. The wind farm control center and grid operator, they're two separate persons, two separate uh, uh, companies mostly of the time, and then they might be talking. I believe they're talking. Oh, okay. I forgot that I put this on a single slide. Okay, so the asset owner management, remote users, remote CMS. For example, there's someone, there's a company selling the service of, okay, I can analyze all your SCADA data and tell you if the turbine number 26 will fail in the next week or not. And in control center, here the remote CMS and control center, there's another thing. For example, we can predict that we need to dispatch a maintenance team in July. Not now. Don't worry. It will not break in the next 2 months. But in July, you need to have a team there to inspect, visually inspect, and change oil. I don't know, take a look at something in July. You don't need to go down now. Okay, that's prediction. There's the problem, Sergio. It's good that you asked. There's the big problem, raw data processing. So data acquired by sensors need to be processed before SCADA. What's the goal? Reduction of data size. So there are many techniques, okay? Time series, so you can talk about vibration, but there are a lot of, for example, if you are monitoring the turbines, vibration will be okay, but we will not observe cracks with a single accelerometer on the blade, for example. Okay, so we need some kind of other sensors. There's an example here from a paper from 2020. It's a Indian turbine, Suzlon. Nominal speed of the gearbox or the generator 30 hertz. So with 32 teeth on pinion, the gear mesh frequency will go to close to 1 kilohertz. Okay, you need to measure that with at least 2 kilohertz, right? Should be more. So they did a test with one accelerometer data from sample at, no, this data from, they did test with more accelerometers, but just show you here. The accelerometer was measuring at almost 100 kilohertz. So if they did a strategy of measuring 6 seconds every 10 minutes. Why every 10 minutes? That's standard of data transmission used by SCADA. What you have is 500 points measured. What means if your Excel datasheet, if you're sending it to an Excel datasheet, it will be 500,000 lines. 1 hour data would go to 3.5 million lines of data. If you're measuring 24 hours, that goes to 84.4 million points or million lines. Next example here, just very fast. This example, I used 32 bits. Imagine that we are recording our data in as integer, so only 4 bytes. So storage for 1 day of raw data would be 345 megabytes for 1 channel, measuring at 1 kilohertz, for example, or it would be enough for gearbox. If you process it, so an example here, if you apply a single discrete Fourier transform, data side would be, so you take half spectrum only, so half of the data will be 1.2 mega, so in 10 minutes, okay? The raw data in 10 minutes will be 2.4 mega. It's discrete Fourier transform 1.2 mega. If you go for a power spectral density, PSG, using a sampling window of 30 seconds, 6K. So every 10 minutes, you can perhaps just send 6K instead of 1.2 mega or even the raw data, okay? I think that this shows why you need to process data inside. the turbine. Here an example for people that want to do some exercise. I'm not doing it, not even at the workshop. Here, I took this data from this. If you click later, you find it. It's anyhow data from a setup, a laboratory setup with. They were mimetizing a turbine. So here, one of the accelerometers, they had 7 accelerometers and data in 6 seconds data, many files with 6 seconds data. So I used Python, SciPy to process the data. The accelerometer, the total data here is 19.2 mega, 1 minute of data. Okay, if we apply a single FFT, here it's showing the absolute of the FFT, not the components. Okay, not the. It's a complex result. So it's 9.6 mega, so half, using the whole window. If we apply a PSD with a Welch with 12 seconds window, then we come to smaller data. It's only 48K. So this is very simple to see. There's the health signal on the left, the damage signal on the right. You can, if there was someone looking at it all the time, certainly the person would notice that something happened to the gearbox. Last 10 minutes, I try to be fast here. So that automatic fault detection, this is the thing going on. Again, okay, so we have the faults, the sensor is installing, were installed, data is being acquired, the initial process was done inside the turbine, data lake is available, we are sending data through SCADA to the data lake. Okay, what's next? Or perhaps not in the data lake. We need to do interpretation, decision, perhaps automation, but important, we need to send alerts, okay? This is a saying also in Brazil, but actually bad news travels fast. They need to travel fast because you need to alert the maintenance team that they need to go there and take a look or change some parts or change oil and so on. Okay. But to do that, here I have this work from 2006, 2005. People were talking about that, so it's not a new thing, completely new thing. We can do prognosis based on data only, or based on models. For example, we can model it and we know what to expect, or we have data and okay, we know that something happened because data changed. We don't know what. Perhaps you send someone to take a look. Okay, this data is changing because, well, the temperature is increasing inside the turbine because there's a nest of birds on top of the radiator there. Okay, so there's an interesting graphic that I found on Fahar et al. Here we have strength of physical model to low to high, amount of relevant. That's an E more here, low to high. Okay, so we need more data here on the right down corner. We need more data and better physical understanding. We don't know exactly what's going on, and we don't have enough data. If we just go on this direction, we have a physics-based modeling, but still we don't have enough data. And the idea is to go to a validated physics-based modeling. So that's why you need to have so many works on laboratory to have a good physics modeling, to understand what's going on. On the other hand, we need to have more data. And in our case, our group, we are not there. We are trying to get here because we don't have real data so far. And this is a problem for research institutes, or in Brazil, this is a problem for academy. So some identification examples from 2012. These guys here, they are trying to organize maintenance plan based on production. They are only measuring the power output of a wind farm, different turbines, trying to locate the wind turbines on a map, a 2D map, position on ground. They use neural networks, some of the methods there they could assemble, build clusters of wind turbines, and from that, they said that they could make a better plan for inspection and maintenance. Instead of sending a team there and going turbine by turbine, what they did, okay, just go to those that are worst in production. And most of that, more than that, they could see that on the map they were together. So, okay, that's a very preliminary work, okay, using only one output. I will give this things here for you to take a look, okay? So 2020, 2023 works. Machine learning methods, for example, Statico et al., he made a review work. There are many types of monitoring. You can classify them into intrusive and non-intrusive, and can time a fault. You can, for example, have real-time fault detection. The fault occurred yesterday night during the storm, and it's there. And you can do fault prediction. These bearings are starting to wear out. They need to be changed in 1 year from now. Okay, so it's prediction. And there's important thing here. So initial task on using machine learning methods is to select the right features. Which are the variables that really relate to the outcome. If you do it wrong, you'll be measuring something that won't show you anything. Okay, some methods here to use that. It's a big data challenge because you have a big volume of data. You need to have good velocity of transmission, but sometimes you don't have. We have variety of data. Sergio mentioned the accelerometer, but it's not that, because you need faults, electrical faults, for example. You may need strength data. You may need, for example, temperature. Something is not vibration, but the temperature is increasing. What's going on? And of course, you need to rely on the data. Okay, we need to say, okay, if it's saying it's good, or the information is good. So okay, so and then feature selection, and then from there you need feature extraction. Okay, these are the variables that that can show something. Next, we need to apply some features. Okay, just to finish here before going to, I use 4 more minutes. This is a work that I participate. I've been participating in the last 5 years. We try to identify mass imbalance only estimated rotor speed. There's this work on renewable energy on 2021. We used to support vector machine on PSD data. So what we had OpenFast, the NRL software, to assemble a framework where we could make thousands of simulations, okay, to assemble a training data set and then the testing data set. So the guys, Guilherme and Leonardo, did a lot of work, and we had hours of discussion on what to do, or what would be the best processing method. Okay, what we got? So we changed the model, OpenFast model, structural model, and then on the structural model of OpenFast, to have a file for the structural side, the structural definition of the blade, and then we changed it on one of the elements there on the tip. For example, we changed it 1% of mass, increased the mass, or reduced the mass 1%, 2%, 3%, and did lots of simulations. And the goal was trying to identify not only the class or how much unbalancing we had, but also where. So which blade was showing this imbalance. So on the right, the real or the simulated data, and here the information we had. You see a cluster of data showing that, okay, it's somewhere here. And this here, the confusion matrix that you saw that it's very good using SVM and PSD. Another work that we expect to I'd say to publish soon. This work of last year that we are trying to detect aerodynamic imbalancing now using CNN. So it's convolutional neural network. You know that it's applied mostly to images, but for example, what image should we use? If you go back here, we cannot use the raw data. You see, it's just a mess. Like everything is blue. There's some tips coming on up and down, so we need to do some processing. And what Guilherme found on the literature, and then we have lots of discussion what to use, and then we came out with only using 2 accelerometer signals that might be available on a real turbine. It's X and Y direction, so on the nacelle and the wind velocity. And from there, okay, I didn't put here the confusion matrix, but it was very good results, okay? So the paper, you can take a look later. Very good results, but we need to transform that data on image. So we have here our image 10 per 10 bits. Okay, it's only, let's say, 100 floats or 100 integer size. Very small. Now, concluding remarks. These are my concluding remarks, my conclusion, main conclusion. So, CM monitoring, continuous condition monitoring, helps reducing operational risks because we can lower maintenance costs. If you lower maintenance costs, we can increase return of investments. We actually need to reduce cost of monitoring itself. It's very expensive so far to put a data processing system there to install, for example, accelerometers on the tip of each blade. It's not being done right now on the industry. If we had one accelerometer, Sergio, on the tip of each blade, I could take lots of information from that. One accelerometer on one direction only. So 3 channels. Research today, maximize information gathered from current number of sensors. We have these sensors, that's what we have. People don't try to buy anything else. Other, minimum number of sensors for complete diagnosis. Okay, we have 10 sensors there. Perhaps you can buy 2 more. Can we install 2 more? Then we increase lots of information. You're trying to improve diagnosis with machine learning techniques. We need to define local processing to reduce data transmission. We are using SCADA. Another very important thing, CM is an integration of disciplines, aerospace engineering, mechanical engineering, electrical. Because why aerospace? Because that is where condition monitoring, continuous condition monitoring is being developed more. Lots of information come there, lots of learning come there. From there, aerospace engineering, mechanical, naval engineering for offshore wind turbines, reliability engineering, statistics and mathematics, computer science for the machine learning part, material science to understand what's going on the blades, for example, information science to organize everything. Of course, electrical engineering, I'm not missing that. They are perhaps some of the most important people here. Featured, combining all CM systems under development. We see people working with gearbox, people working with blades, people working, I don't know, with tower, but they are all separated. We need to bring them back together. Okay, they need to work together because the turbine is a single machine and everything is working, happening there. Future intelligent blades, as we have intelligent wings, you might have intelligent blades with individual pitch control and so on. We need self-diagnosis and fault mitigation. Perhaps very soon, I believe that we have autonomous turbine. No one needs to go there to see anything. And from there, of course, if you have an autonomous turbine, you have an autonomous farm. For example, we can have drones, dogs taking a look around the farm, or flying drones to go there and inspect if something goes wrong. So be aware of drones, of course. If you try to enter the wind farm, perhaps they will tell you to stay away. And okay, that's it. In the end, it was very fast, but I think that I could send a message. So this is the condition monitoring challenges presentation. If someone wants to talk, this is my email, and you can start. So GEPOX, the group that most of those two works were done, and I worked together with Núcleo de Mecânica Computacional and Grupo de Inovação Multidisciplinar at Cachoeira do Sul. Okay, thank you. Lots of reference here for people have fun later. Okay, no questions right now. Okay, Yoshi.
Carlos, congratulations for your presentation, and a very interesting topic for monitoring and try to find detect faults. So you come from aerospace engineer, and of course, airplanes cannot have failures in your components. So from your perspective for wind energy, why do we have so many problems in your applications? And what do we need to improve from this monitoring, conditional monitoring, to reduce, and say, as you said, to have an autonomous turbine? So what's what are the priority for the sensors and the components to avoid, to reduce these faults?
Okay, so if we talk about airspace or mostly commercial airplanes, what happens is that you have lots of people flying there. Okay, so for example, there's this series on Netflix about the disappearance of the NEH 370 airplane. And what happens? They had their sensors monitoring the aircraft, and then the aircraft would land, and would send information, and perhaps if information is not good, the airplane would not even take off. At that case, there was not the information was not being sent adequately, so people could not find the airplane. Okay, so things improved from airspace. So lots of things are going on because you don't want an aircraft to disintegrate in the air, and not only not take off, but during the flight, it perhaps may land safely. Just go back to the closest airport, or release fuel, and then you land safe, and you save lots of lives. In the case of turbines, what happens? Well, the turbine is there. We engineers, we want to have information. We want our turbine to work safely through 20 years. But that's not what happens. Okay. And then actually, I'll talk about that on the workshop here. That's the idea, to have a discussion. Okay. And because what happens, the industry, it's not that interested, because sometimes it seems on knowing everything about a turbine, because it costs. It's costly to install lots of sensors, and it's not cheap to send all this information, and sometimes they rely on the traditional methods. Okay, the power is not good, send someone there to take a look. Okay. And then I believe the one big challenge is to convince that condition monitoring can reduce lots of costs. But then to do that, we need to reduce costs of the condition monitoring itself, and we need to rely on condition monitoring. Okay, I don't know if I'm answering or I don't know
Yeah,
if you believe,
yes.
if you agree with me, because
Yes.
you see, we will have wind farms on the shore, far from the shore sometimes. In Brazil, it won't be that far. It will be on the continental platform, okay, but still, it might be 100 kilometers from the shore. Are you flying there? Are you send a boat, or there's a storm? What to do to check the turbine because everything fell down, and then there's no power coming on, and then it affects the grid. Okay, then when we think that we are relying more and more on renewable energy, that is where the energy is coming from. So if a wind farm just stop producing suddenly, we need to be aware of that. Okay.
Yeah, yeah. That was kind of a provocative question because I think for our wind energy industry here, when they buy when they develop the turbine, they should have all these monitoring uh, before the operation. Like I said, for airplane, you need a very complete sensors and monitoring
Yeah,
to
but it's
take
still
off.
you have lives inside it. If a turbine falls down and perhaps kill a cow in the southern farms of Brazil, okay, no, that's a cow. Yeah, but the owner of the land is getting some money, so it's a cow, not a problem. But
Yeah, they
if an
install.
airplane falls and kills 200 people, that's a different thing, right? So yeah. I think
Yes,
there are lots
like
of
we
things,
have
different
here
things.
in Brazil for popular cars. You don't have any more popular cars. The start car that go to the market, they have all the security
Yes,
components
yes, that's the point.
to sell. That's the point. I think the turbines should have the minimal monitoring
No,
for
yeah,
more safety, more.
they do have a minimal, but the minimal is what you find on IEC, for example. But minimal is not enough anymore because okay, you can discover more things. The minimal will tell you if the turbine is standing and producing, for example. All right,
So
that's a minimal.
that's the point. So that's the point. The minimum is not enough today. You need more.
No, no, because we are eager to do more. For example, we can discover if the blade is good or not, or if you Cesar wants to ask something, but just finish here. For example, do we need to change the blade in 20 years or in 10 years? This farm is operating for 10 years. Perhaps it could operate for 10 more or 20 more, but then the blade fails. And sometimes the blade fails because nobody knew that there was a crack uh, growing on inside the blade. Okay, this is the point. And we see lots of things going on like that. Another thing that I didn't mention here, just to come back to the other presentation here, for example, in this work, aerodynamics, we did some research on what kind of aerodynamic imbalance or aerodynamic defects we might have. For example, one big problem is leading edge erosion. Leading edge erosion reduces the aerodynamic efficiency of your blade. Aerodynamic efficiency, you reduce torque. You reduce torque, we reduce power. Okay, and then as we discussed, I think Wednesday, we need to send a drone or a camera, and it's not cheap. It's not cheap. It's not cheap to send someone there and to send a drone. And at long run, perhaps it might be more expensive to install accelerometers or to install a set of sensors. But at long run, I believe it would be cheaper to know how the turbine is operating, what's the condition, what's the health, and then you can extend life. For example, instead of having 20 years turbine operating, you might have 30 years. That's a good. Uh, okay. Well, let's see. Tadeo,
Okay, thank you,
Cesar
Carlos.
wants to say something. Cesar, please.
Good morning, Professor Carlos.
Morning.
As everybody knows, there is a trend to use gearless wind turbines.
Yes.
Gearbox is the main cause of higher downtime in geared wind turbines.
Okay.
In direct drive turbines, the generator becomes the main focus to maintain its normal behavior,
Yes.
followed by the main bearing. I have to you two questions. The first question is, how can we use vibration analysis, for example, to detect winding, fault, or short circuit in those generators? And the second question is, do you think that it's necessary to study heat transfer inside those generators to detect such faults?
Yes. Okay. So about short circuits, I don't know nothing. I didn't do any research, but about bearings, there are lots of works. If a bearing starts to wear out, you have lots of effects. Okay, you can see if, for example, there's erosion, the signature, the accelerometer signature of the bearing will change completely. You start to have noise, for example, noise that was not present. If temperature increases, perhaps you have plastic deformation. If increase too much, it will increase because it's something rotating, right? It always increases. The temperature is high on a shaft that is rotating, of course, and you have oil there to reduce friction. And perhaps there's something, for example, you start to wear out and then you have particles on the oil and then you start erosion. So these things all, they happen at the same time, okay? And it's not me that is saying that. Here, it's a review of failure modes, condition monitoring for large-scale wind turbine bearings. So we can take a look at Liu and Zhang. And it's not the only work. Okay,
I know this article.
Okay, so you have find from there you'll find lots of things because bearings is a problem in any industry. I have a graduation student right now that will work on bearings for silos. I don't know the name for rice silos in south of Brazil. Okay, so you can apply it everywhere, but still. Now about temperature. Temperature is already a mandatory signal that must be measured. What happens is the temperature, you can send it, it can measure 1 point, for example, or it can measure at half hertz one time at every minute, and then you have an average signal of 10 points. Just divide by 10, sum and divide by 10 and send it through SCADA. It's only one integer there, 4 bytes perhaps, or 8 bytes. So
That's
it's very, yeah, so it's very easy to send this guy.
That's
But
the point I asked to you, né? I asked to you if it's necessary to detect, for example, each component inside the generator, for example, stator yoke, winding,
yes,
air gap, rotor, shaft, bearing. Is everything possible with some equation that exists in literature?
No, what happens is that you can, for example, what we are trying to do, we have this is another problem that we discuss. We have FAST, a model, and there we can, in the model, it's a numerical model, we can introduce some faults, okay? If the model is present. But for example, pitch error. I don't know. I don't know exactly what's your field, Cesar. If you are talking about the same thing.
I'm just working with detect fault in generators in wind turbine using physical models.
Okay, yeah, but
MSC.
yeah, but for example, do you know what's the individual pitch control?
Yes.
All right. So, for example, if you try to control every blade individually, all right. But then to control, Yeah, I believe you're in the control area. You need a sensor.
Engineer.
Okay. Yeah. So if you have a closed loop, you need to inform something to the controller, right? And if you have an error on the pitch measurement, you will introduce vibrations, but you don't know exactly where this vibration is coming from. Because what happens in a real turbine, I don't know if you have real data. Do you have real data from VAG, perhaps? Are you working with VAG?
No.
Yeah. Think about a real turbine. The signal is coming very dirty, very, very dirty. There are lots of things going on. There might be, you are lucky if only one fault will happen there. This turbine perhaps will have a degraded uh, uh, leading edge. Perhaps you have
Okay, I understood.
rates is
If the
okay,
sensor reads an incorrect signal, they send to an
incorrect.
actuator, hydraulic actuator or electric motor to control a wrong angle to the pitch control.
Yeah,
So
and then you require
when
your
you have
pitch.
a fault pitch control, so then you have a fault pitch control. Yeah, I
Yeah.
get it. I got this. But I'm asking to you, when we get a gearless wind turbine,
Yeah,
forget about the gearbox. Is
no,
that
but still, yeah,
is that trend? It's a trend.
again,
You know, it's a trend to retract the gearbox, no?
uh,
Not one wind turbine on versus with 10 megawatts is using a gearbox.
yeah, but
But
still, do you take a look at this? Are you seeing my screen?
yes, I'm seeing.
Yeah, it's a drive. Doesn't have. It's a direct drive, but it still have gears. We have at least
Yes, we have gears in the
we have lots
actuator.
of gears.
Yes,
Yeah, we have lots of gears. We have gears on the
correct.
yaw system. We have gears on the pitch system. So there are
Yes.
gears still. These gears. They work in low speed, but still, how many teeth do we have on the yaw control? And perhaps you see here in this picture how many motors are controlling the yaw. We have
Mhm.
7 motors controlling the yaw. What happens is if one of them fails, the load will go to the other 6. What happens if another one fails? Okay, we have 5 motors controlling yaw. If what happens if one of the pitch control system is wrong, like this motor here is working much more than the other 2. Do you see the problem? The problem begins to increase. So if you think on a big picture, different systems working together, and that's what I see right now. Again, if you take the direct drive, if you take the gearbox, you are sending everything to your controller, to your inverter, right? Everything is controlled by your inverter. So there's a lot of temperature going on there, I think. What's the temperature that you might find on one of these cabinets in a direct drive? Because there's lots of things going on, right? Yeah, and then it's a short blanket or cobertor curto in português, right? Short blanket. You are removing the problem from one side. Gearbox, okay, we don't have gearbox, great. But then you have problems on the electrical side, on the power control side. Then, yeah, you have the FIG. We have other configurations that might try something that's less problematic on one side and less problematic on the other. But I still don't know the numbers exactly. I'm not the right person to tell you that okay, direct drive is the best for maintenance. Okay. I don't know if you agree with me, but that's what I think about it.
No, no. It's only read some articles and then you going to see some suggestions from the others. It's not absolutely truth.
Yeah, still. People, okay, so my idea for the workshop was this. was actually discussion and planning, but only with questions. We are already at 10:28. Sarah asked for 10 minutes break. I don't know. I actually don't know if I do the workshop, because what I was trying to bring to you here is actually discussion. Okay, that's what I think. But for example, on the business opportunities, I right now I'm in university, but I have my small consulting company. I began. Wait, yeah, 1 second, please. I had this small company. I worked in the industry, on the industry floor, let's say, and research opportunities. I think that condition monitoring poses opportunities for everyone in Brazil, at least. And I know that there are some small companies doing business on this field, but still it's not continuous, and it's only one topic. But Hoyt, please, you raise your hand, please. You can pose your questions, Hoyt. Can you please comment on the PHN Foundation part? All right, okay. Now I saw your question here. Sorry, it's 6 minutes late. Well, again, I can comment on PHM or foundation part. Okay, just come back here on this work specifically. Oh, sorry. Okay, so but I am much more. This is another topic that I am trying to learn more. Okay, about foundation of floating turbines. But for example, these guys here, their work was specifically that. For example, the grout sensors, they were trying to observe specifically the displacement of the foundation. Why that? Well, because with that they can see, for example, if they have a buoy somewhere on there must be a buoy near the farm or inside the farm. For example, we can make some kind of response function. Okay, so you have a wave entering and you have a response. You need to measure grout sensors, and you can see there, okay, the displacement is above what we want to have, right? And what should be the frequency of that measurement? For example, these guys here, they use a 50 hertz measuring for 24 hours, and they are still trying to identify, okay, what sensor do you need to have to identify this kind of problem? And as we know, there are different kinds of foundations. Because there are different types of seabeds, and then again, there are different types of wave on each site. And I think that this is a specific topic that must be. So, I don't know where you work, or if you're a PhD student, a graduate student, but I think that this is a really, really nice research topic. But just to give a hint, I don't know if I answered your question, but research student. Okay, so I think that this is a very, very nice topic to study, because what would be the displacement, acceptable displacement of the foundation, right? So I guess Paulo has a question.
Okay. Just to position my question, control and condition monitoring is part of my background for a long time. I'm quite new on wind power industry, so I am right now doing studying at UFMG here, trying to learn more about this to be able to work on it. So my question to you is, it is absolutely clear the importance of condition monitoring and the benefits that it can bring not only to maintenance but also to operation. I would say
Yeah, control.
optimization of operation. Those are the two main areas where condition monitoring can help a lot. But what I'm going to ask you is, how is the perception of the wind power energy related to this? Because in other industries where I am familiar, I can say that it took a while, it took decades for them to reach a position in which they start looking at it and saying, okay, this may be fine. Why not trying to start using it? But in all the times, it's always followed by a question, which is, okay, how much does it cost and what's my ROI? So can you elaborate a little bit about the experience of wind power industry related to the accepting or not the concept?
Okay, yes, this is a very good point, and this is a thing that I actually put on the workshop to discuss. Okay, what I see in Brazil is, well, my experience is that it's very hard to start a program, a research program, or a discussion with industry. They just don't care much so far about this. Last year, we in the contest of this grants for PhD R&D from ANEEL. Okay, I participated in a group where we tried to insert a condition monitoring system, and we didn't win that grant. I don't know what happened, because actually we didn't have any answer. And our initiatives to talk with industry failed completely in Brazil. All right. If, for example, I don't know if Ciro is here. There's a student. There is a master student of Federal University of Santa Maria of Rio Grande do Sul that works at DNV. And for example, we cannot mix things, right? And he worked in a small company in Pernambuco that did some service for farms in the northeast of Brazil. But then what I see is this: we have small business and people, when they need help, they will contact someone, they will go there and do the service for them. Okay, they do some inspection. I have a friend, a former student of mine, he was working at Siemens, and he just mentioned that, okay, I'm going to Bahia to a farm, to wind farm, and we are installing some equipment there. It's a campaign. So what happens? Industry goes when they need some answer, they need some backup, okay, to understand what's going on. They call a company and they have a contract for 1, 2, 3 years, I don't know exactly. So what I see in Brazil is that too close. And I was hoping in this workshop actually to learn more from the company side, from company sides. We know some people, one guy here, another guy here, that they give us some information, some informal information. They don't have a report. We don't have anything going on. So this is very difficult so far. And what happens so some of these works that I showed, for example, Fremeliev, here, he works at Siemens Gamesa, and he published his work. It seems that they are interested in this thing, right? Because they are doing some research on that. They have a test stand, they are installing, and they are trying. But I don't see that in Brazil. Okay, even WEG, WEG's I think it's very difficult to. I have some former students working there. I have people inside there, but still they don't look for us. And if we talk about Professor Humberto Pinheiro, that's on the control for decades, he has lots of former students working at WEG, and still it's impossible to start a cooperation with WEG. That's this only manufacturer here in Brazil that could, for example, help us. We take, for example, Aeris. I never heard anything from Aeris. Aeris is a blade manufacturer. Their blades are designed by LM, I believe, or some other company, but they are manufacturers. also I don't know nothing about what they are doing in these terms. Or for example, installing, what sensors are they installing? I don't know if it's okay if you believe or if you agree with me, or it's okay. Did I answer you?
Oh, yes, you completely did. And my experience on the subject in other industries is that the technology supplier or the technology owner was indeed the one leading actions towards this. Leading action because, as you said in the beginning, it's not only having sensors, it's what you can do with them.
Yeah.
How you handle them and what you can do with them. So what you can do with them is pretty much linked to your knowledge on how to run that. So in other types of industry, technology suppliers have been the ones more successful to help pushing condition monitoring, but always or most likely attach it to service contracts. So in
Yes.
how to keep the installation healthy and how to extract the most of it.
Yeah, this is the problem. For example, if we start a campaign with a running wind farm that is already running for 10 years, what should they do? First, we need, for example, to model the turbine as much as possible, but the blades, if we don't have the information of the blades, well, I could do that. If someone pay me, I could do that. Okay, I will do my best. I did that with aircraft. I could do that. But still, what would be the best? Using data based from the beginning. First day of operation, we have data, and we are collecting data, and now we know about this turbine. And while we're running tests and commissioning the farm, you already know what's going on. And then in the future, in the next 5-10 years, we can do very good predictions. But I don't know. But we can find, for example, works from China, works from Denmark, or Netherlands, where they tell that they were 1 year monitoring one turbine and they have good results. But then here in Brazil, I don't see it going on. Okay, and I think that that's what I think about that. What are the challenges to implement CM strategies in Brazilian offshore farms from the beginning? See here, I tried to pose this question. There are no farms so far. Can we start from the beginning? That would be great.
Absolutely.
Okay, people. Actually, the workshop is going on already, right? I think that we have 10 more minutes, and then we can have a 10 minutes break.
Oh, Carlos, one more
Yes.
question.
Yes.
Uh, uh, for this monitoring system, usually the 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 manuscript I have some reviews. They don't focus too much about some extreme events, strong winds or lightning. So how this monitoring do you know any reference about this for extreme conditions and how this uh, monitoring system can avoid these for fault or
Yeah. I actually.
maybe I reformulate my question. So if you have like a gust, extremely strong winds, uh, do you think this controlling system of the turbine can avoid these uh, overloads or some
Yes.
problems, or what does what is the decision for the operator to like try to turn off the turbine, or the system, the controlling system will be safely turn off the install the blades and no damage you occur.
Okay, so Gus, very interesting because it's recurring research in aviation. Okay, so for example, I did a campaign of aeroelasticity on a Brazilian fighter, F5, where the pilot was supposed to fly with the autopilot or use the dumping system on and the dumping system off. And it works, okay? So I believe that the technology exists, but it's applied to other fields, aviation. It's only a question of bringing it to the wind turbines. Where could we? Which would be the controller? I believe the pitch systems, and also perhaps you can, for example, if the gusts, well, you believe we will start from the beginning to know better your farm, to know better your site, and then you certainly will know where the gusts mostly comes from. Okay, where's the direction of the gusts, and perhaps you can, for example, think about autonomous farm. If the turbines that are on the gust side or where the gust comes more, they need to be prepared to protect the others with their, or for example, to with yaw systems so that their wake won't affect the other turbines. But I could think we could discuss hours, okay, Yoshi, about this.
That's a good question.
Yeah,
this is because like there are some airplanes, they have a radar that can detect thunderstorm ahead.
yes.
So that you mean maybe autonomous farming should have some kind of
sure, yeah. Yeah,
like
I believe the autonomous
radar
farm.
to.
Yeah, what I think about autonomous farm, for example, this farm would be connected to the forecast system, and they could be talking with the closest meteorological stations. And of course, again, you know what's the price of one meteorological station, I believe. You work in the field. So believe that, okay, so maybe we can make it cheaper and we can install, instead of one, we can install 4. Would it be a dream for you to have 4 stations around the
But should
wind
it be
farm?
necessary in the case that's my question. So
I don't know.
do you think that this controlling not just the turbine controlling but the wind farm control can avoid these
Yes, I believe it can.
these extreme events
Yes.
just for using this condition monitoring, or do we need these plus instruments for weather system to detect this?
Again, look at this. Where is that? Where is my presentation here? We need to know the signal, what we want to measure, and then we can add more sensors. Another kind of research going on aviation, for example, is the swarm, control of swarms, drone swarms, for example. And you see on the Olympic Games, on the lots of games or soccer, that you see drones flying and forming figures on the air, right? This is a swarm control. Oh, it's possible. How do they control that? Okay, one drone is sending information to another. Okay, so for example, the Saab, the Swedish aircraft manufacturers, their fighters, they have a network. So there's a fighter flying 100 kilometers ahead of the fleet. It will be sending informations, lots of information. So for example, there's an enemy coming, or the weather information. So there's a lot of information going on the aerospace industry, swarm network of information. I think that it would be easier to bring this knowledge to wind turbines, because one thing, the turbines won't be floating around. Okay, they won't be, perhaps in the future, they might be looking for the wind in offshore, but they will standing on the same place. And the technology exists on the aerospace side. It's a question of someone or people will start bringing it. And then I believe I saw something at U Delft and Denmark, I forgot the name. DTU, for example, people are studying that. Okay, types of control based on information. What information? Lots of information. And I sincerely believe that we will get at some point not only the autonomous turbine, but the autonomous farm. It's a path to be followed, and research opportunities. Anderson, I think that there was someone, or I don't know who was. Anderson was trying to ask something. Anderson Ribeiro.
Hello, Professor Carlos. Can you hear me?
Yes.
Actually, it is quite more like a curiosity than a question properly. You mentioned regarding all this work done by your research group, you mentioned some data analysis, right?
Yes.
I was wondering when you were talking about the difficulties on establishing some partners with the industry here in Brazil. This data come from partners from outside the country, or
No.
Federal University of Santa Maria, you have a facility, wind turbine, or something like that?
Thanks for your question. No, the data is completely numerical data. We use this guy here. Let's see if my Zoom doesn't go too far. Okay, we using Fast, and now we are using OpenFast in the new version. It's a software by NREL. It's an servo aeroelastic software. We have Elastodin, Servodin, InfloWind, Aerodin. And so we can simulate turbine from the rest. Okay, so wind start increasing the wind, and then we can model different types of wind, random winds, and inside that we have the Servodin. We can use Simulink, for example, to change the control, but our work is only numeric. Okay. Now, the other point here, Brazilian research and development infrastructure, we don't have. We have small groups. Perhaps someone will have. I see. I know at ITA there's a turbine. Okay, have you ever been to ITA in the last 10 years? So near the library there, ITA in São José dos Campos, you see a turbine, but it's not running because it's the middle of the. There's no wind there, basically. If it was near, for example, on the top of the hill where the radars, but then it will be there will be interference with the radar, so they didn't put it there. There's a stop-it turbine. I don't know how many kilowatts. I don't know if 50 kilowatts have. I don't know if anyone here knows about it. But we don't have a research and development infrastructure where we could, for example, install a 2 megawatt turbine and start playing with it. For people from FMG, from UFSC, from ITA, from USP, everyone could go there. And this, okay, 10 to 11. But people, guys, I believe that this is a very important thing for us, and that's why I gathered with you and I offered to present here. We need that. Okay, I don't know if you agree with me, but I sincerely believe that we need a institute, for example, where we could install some turbines and could go there, spend a month installing sensors, come back, and then receive this data remotely, for example, and do lots of things, change blades, change gears, use a direct drive turbine, I don't know. Okay, Anderson, that's it. Understood?
Okay, thanks.
All right, people, I believe that we can have a 10-minute break here. I could, as I said, I could, if we were on a dinner, we could go on forever, but perhaps in the future we can talk more. I'll stop sharing, and I think that I'll wait for Sarah. Okay.
Okay, congrats, Carlos.
Thanks, Carlos.
Thanks, Carlos.
I'm in the
Hi, everyone.
Hi,
Hi,
Sarah.
Sarah.
Oh,
Yeah.
Carlos is finished.
Hi.
Yes. Hi. Finished.
All right, good. Good. And how is everyone else? Still motivated for the final part of the workshop?
Yes.
Friday afternoon. For me, anyway. All right. So, does anyone any questions before, or anything they need from us before we start with the last part?
I just need later to know how to share my presentation with the PDF file. I didn't get exactly where is that shared folder, but then we can do it in the afternoon or after this last presentation.
Yeah, but you're supposed to be presenting now, but you can just share your screen if you want.
No, the presentation that I did now,
yeah.
just a file, so there are lots of reference there, so I think that people might want to follow those links.
Yeah. So there's I'm sure that we have this Google Drive, right?
I just need to find this.
I can put the link in the chat again. I mean,
All right.
It will be good for everyone else anyway. I'm just trying to. So we have this folder called lectures, but I created a separate folder for the participants. It could be a problem that it's just viewer. Anyway, I'll put it in the chat again, and that you can just I've got some subfolders: lecture notes, exercises, other admin, and so this is actually to all the lecturers. If you want your lecture to be available to the participants, you have to move it yourself from this folder.
Actually, Tara, I think we don't have the permission. That's why I sent you an email.
Yeah, I just saw that. I just changed it just now. I just saw that I put it on viewer instead of editor. So you're right. I didn't. I did that wrong. But and it's also perfectly fine if you just tell me, and I can do it as well. I don't mind either way. But if you want your lecture to be in the shared folder, you either have to now to try to do it yourself, or just tell me and I'll do it. That's also not a problem. But the participants only see this folder. And so the idea of today, you can see my presentation screen, right?
Yes.
I'm sharing the right screen. Sometimes I share the wrong screen by accident, so that's why I'm just checking. The idea for this last part of the workshop is that we have, all the lecturers who are present now are going to do a short presentation about the research that they're involved in. And then after that, we're going to have a discussion amongst the lecturers where each lecturer says their perspective as a summary, or maybe they learned something this week. Sorry, my internet breaks once an hour regularly. You can hear me again now?
Yes.
Yeah, sorry. So the idea is that the second half hour is each lecturer tells you what their main challenges are, and I'm going to make notes while you do that. And then the second part from 4 to 5 is we're going to split the participants into we're going to have a Q&A. Then we're going to split you into small groups and ask you which challenges you think are missing and how you think you can contribute to these challenges. And after that, there'll be you can present your results back to the group. So let me just try to work out which lecturers are actually here so I can work out how long each presentation should be. So we have Yoshi, Victor, Ingrid, Carlos, and me. So that's 5. Is there anyone else? Okay. So, and we've got like 20 25 minutes. So we can do 5 minutes each, or we can do a bit shorter. If we do a bit shorter than 5 minutes, then we can have some questions as well. So shall I put a timer on so that you know how long you're speaking for? Because sometimes it's quite difficult to know how long you're speaking for, right? Should I do 3 minutes each, and then after that we'll see if anyone's got questions about it? Yeah. Everyone, are you happy with that? Everyone, lecturers?
Yeah, I think we can.
Okay.
Yes.
So I'm going to do it in order of the appearance of the lecturers. So the first, I think Ingrid, you put your slides inside the presentation, and my slides are in there, and Yosh's slides are in there. But I think Carlos didn't have access, and Victor. But you two can just share your screens if you've got something to share. So when your name comes up, we can transfer over to you. Okay, so Ingrid, do you want to take your 3 minutes and just tell us all about what you do?
Sure. Well, I did the first lecture. I think most of you attended the first lecture. I presented more of a market aspects because this is more related to my professional background. I also have an academic background that I didn't tell you in the first presentation. I'm an energy engineer, and I'm pursuing my master's in ocean engineering. It's taking, let's say, a little bit more time because my research is more complex than my background, and I work in consulting. So let's say I have, let's say, two hats. The consulting that I work more with market, with companies. I don't, in my professional life, I don't work with research. Um, Now I work with technical advisory. I think I mentioned this in the first day. I work a lot with due diligence, construction monitoring, operation monitoring. Basically, we do follow up. We try to, let's say, simplify the technical language to the lenders, to the banks, that they finance the project. So basically, this is what we do. And for doing this, sometimes it's really good to have a technical background, because there are some issues that we see in the projects, and if we don't have a technical background, we wouldn't provide a good advice, because we also need to say if we are satisfied or not. And I also work at some time for market studies. I don't do this so much anymore. So the exercise that we did in the first day about site selection, I did a project. This was one of my first projects as an independent consultant in 2020. I also did a lot of not a lot, but for two companies, I presented a little about the energy market in Brazil, and also the relevant regulation for offshore wind, and some of our perspectives for what was probably going to happen. And I also did some risk assessment, which is also something that really is in common with what I work now, due diligence, because we need to point what are like the main issues that we find. And for my academic research, all of my researchers were in offshore wind, even though I was living in Brazil. And it was a time that sometimes people don't believe it was going to happen. And my research was always in in floating offshore wind, which is now something that here in Europe is starting as commercial projects. And my part is more hydrodynamics. It's like the everything that's like in the water line or below water. But even though I'm working in this part, wind is something really essential, because for hydrodynamics, the main part of the wave model is based on the wind model. So that's why we also need the wind details. And one of the now the because of my master's is between it's a combined model with floating offshore and wave energy. They are very opposite problems, because in wind, same as in the oil and gas industry, we try to avoid the resonance regions of the movement. And in wave, it's exactly the region that we need to generate the energy. So we need to pay attention. And one of the other very interesting details of working with combined models is that even though sometimes you can also like design your wind converter, your wave converter for not the, let's say, the main resonance area, it will also, let's say, protect the structure of the turbine. You will also have like this shadow effects of the wave in the structure.
Okay, run out of time. Sounds good. Hydrodynamic aspects, you could probably give an entire lecture just about that topic.
Yeah, definitely.
Or couple dynamics. Okay, then let's go to the next person, who is actually me. Let me just set the timer for myself. Yeah, so I gave the second lecture on the first day, if some of you missed it. So my name is Sarah Barber. I lead the Wind Energy Innovation Division at the Eastern Switzerland University of Applied Sciences, and I'm president of the Swiss Wind Energy R&D Network. And we're basically trying to provide solutions for the global market. So the Swiss market is not very big or interesting for us, but it's important for us to apply interdisciplinary research, because we really believe that, you know, the wind industry, it needs lots of inputs from lots of different people with different experiences if we want to really be innovative. And the other thing is that we are focused on things that can be adopted effectively and sustainably by people. So there are many people who do detailed technical research, but they don't necessarily work together with the people. So that's kind of our focus as well. The main topic covering everything we do is digitalization. So we have smart measurement technology. This is an example of a project where we're building a pressure measurement system, which we can stick onto blades, and everything is enclosed inside of a 4mm thick sleeve, and the data is sent to the cloud, and we have a digital twin which is analyzing the data. We look at knowledge engineering and data modeling. So if you want to use artificial intelligence systems to automatically, you know, make decisions or do operations on data, you need to structure the data in a consistent way, and so to do that you need ontologies. And so we're looking into that quite a lot as well. And then we do data analytics and artificial intelligence. So for example, we're looking at genetic what's it called, graph neural networks for looking at wake effects. I don't know if Raphael talked about that yesterday, but it's one of the things we're doing. We also look at digital twins and decision support. So how can you help people decide things based on the data? And then also fair data and science is a big topic. So fair data means findable, accessible, interoperable, and reusable. And it's kind of a defined thing that if you want people to be able to share data with each other, it has to be fair. And so we have several projects where we're trying to improve data sharing. Our research expertise is flow modeling and mountainous terrain. In Switzerland, we have lots of mountains, so this is important. We have a few projects on that, but also then rotor blade aerodynamics based on the measurement system I told you about. Also system dynamics. So our measurement system has accelerometers inside it as well, and we try to use that to work out the dynamics of the entire wind turbine. And then we actually try to research into collaboration methods. It's not really our main competence, but we work together with people who look into collaboration methods, so we can really get people involved in collaborations. And then also we do look at diversity and inclusion. So I am in the diversity committee of the European Academy of Wind Energy, and I really think that it's not a separate topic. I think it's a topic that we have to consider in our everyday work. If we really want to be innovative and have some great technical solutions, we need encourage all different types of people to take part, which is actually one of the reasons I'm interested in this, working with all you from Brazil, because I think there's so many people hidden away in lots of different countries who don't necessarily get access to the European industry, and that's what we're trying to do as well. So yeah, that's the end of my presentation. Ina's not here. Louisa's not here. Wilson's not here. Victor is here. Do you want to share something, or just talk, or however you want?
Yes, in fact, I had no time to prepare a presentation, but I have some old presentations here, and so I'll talk a little bit. I'm professor, yes, professor and researcher. Yes, and so I work at the Federal University of Minas Gerais, and we have the graduation, undergraduate, and post-graduation courses, and we try to develop projects, and sometimes the projects are not very focused and just in wind systems. Yes, I am the leader of the Laboratory of Energy Conversion and Control. Yes, and now we have four doctoral students, 4 master students, and we work, as I said, not just in wind energy conversion systems, but also in photovoltaics and aspects of control and grid integration of these systems. Yes, and when you talk about wind photovoltaics, that it's very important in these days to talk about other topics like energy storage systems, and so I work more in this kind of system. We focus with the grid integration, as in mainly in the electrical part, in the in the power electronics part. And so most of our development is based on experimental systems, and as it's kind of hard to develop some studies, for example, in a full-scale system, in a megawatts wind energy conversion system. So in the laboratory, we have some test bench that represent the different technologies of wind system. And here, for example, we see that we have a small system of 30 kilowatts with a doubly fed induction generator, and it develops lots of research about the power electronics, the control of the system, the grid integration. We have also another test bench with permanent synchronous generator, and I will not give details of this, but just to show you that we have this experimental part. It's something that's very important, but we do this with small scale test bench to after if possible, it's to implement this in the real world. Yes, and this it's an old project. In fact, we don't work today much in this type of system of to develop the generator and small scale turbine, but in the past we have done this. Yes. And today one of my topics that I am very interested, it's the use of multi-level converters to increase the power, and also to have fast dynamics for the systems, including, and it's very important for wind energy conversion systems. And so we work a little bit in this topic of multi-level converters. And I'm not sure here, but we have some projects, and also we work with the photovoltaics. Yes, because Even if we have a system, a wind system, where we have a generator, that's a rotation machine, and we have a photovoltaic system, that's a panel, yes, but the grid connection, it's similar. Yes, and so the control strategies, this kind of integration to the grid are very similar. So because of that, we work with this kind of photovoltaics, and also for um, um, energy storage systems, yes, and high power energy storage systems, also using converters to connection to the grid. And so I am very as I can say, it's my topic. I'm passionate for of the topic of renewable energies. I am always looking to spread this knowledge. I am the coordinator of post-graduation course here at UFMG, just for renewable energy systems. Yes, we have already formed a lot of students in this. Nowadays we have a class, and so I'm always trying to spread, to teach more and more people about the topics, because it's I see that it's very common here in Brazil, that we see people that work with the systems, but they don't know exactly the whole system. Yes, maybe the person is just working, for example, with the resource for photovoltaics or wind, for example, but don't know about the whole system. And I think that this is very important, not to know deep, but it's important to know about the components of the system. And so I'm very happy with this workshop, where we could see different topics: blade design, the electrical part, the wind resources, and to know everyone here.
All right. Sounds good. Thank you very much. Now, Yoshi, shall I share? You've put a slide, haven't you? So I can share my screen. I can share your slide.
Yes. So my slide was about the challenge, not my background, but I can summarize part of my experience and my research topics. So from my experience, I have been working for wind energy since 2001, when I was a technician to install mat masts and instrumentations, and I was one of the first to install many mat masts in Brazil, in the Northeast, in 2001, more than 20 years ago. So that was my first experience with wind energy. And so after I have some experience in the, uh, the field, I decided to do my master degree. And so I have worked with research in wind energy, uh, that we started in 2011. And then since 2011, I have been work and have more activities in research. And that's when I started as a professor here in Federal Institute of Santa Catarina, Florianópolis. So my experience started with instrumentation, the data acquisition. So I have a good background of this. That's why I have some question with Carlos, and I like a lot of condition monitoring, and I'm interested to do to this. So, but my core today for research is about resource assessment, and my PhD was to understand the effects of turbulence and the wind profile and over the performance of wind turbines over 2 wind farms. And from these, I use a lot of SCADA data that I was also interested to understand the turbine, and so I have more. I have been working with SADA with 2 manuscripts related to failure of wind turbine using SCADA data. That was really nice here in this we do windy space. So my research now, if you Sarah, you can share the slide now. I have working right now with 2 topics. I have been collaborating with Federal University of Rio Grande do Sul. That there are a lot of participants here, and so I have collaborated with them. And the research is about resource assessment in the offshore condition, and I'm now investigating the boundary layer and the effects of the stratification that occurs along the coast. That's the first map here. You can see the difference of the temperature of the sea surface and the air, so that you can have different profiles here, more stratification when we have this negative difference of temperature. That's one result, and I'm developing with them. The second one was more theoretical and try to develop a method or extrapolation that can go above the 200 meters, that go above the surface layer. There are a lot of issues and challenging over there to understand the wind above that, because the theory just is limited, restrict to the surface layer. So that you can see the second graphic here, that the wind starting decrease with the height, and there is no theory today to do this, to describe this, and that's we are working on this right now. So I also, in my PhD, I have a lot of experience with simulation with WRF and how to understand these wind conditions related to the boundary layer. So that's my experience, and the screen show my results, and also with the challenges we are dealing with this topic. Okay.
All right, great, thank
And
you.
so thank you everyone for this workshop, and for all who was interested to all this presentation. Was really nice. Unfortunately, I could not attend all this presentation. I would like to attend all, but most of them I could watch, and it was really nice, and that was good experience in this workshop to understand different topics.
Great, thank you. Yeah, and thank you to everyone for those presentations. Does anyone have any questions they want to ask us about what we do, what we presented, our research?
One question that we discussed during my presentation a few minutes ago, and you showed yours, and for example, Victor showed his, is that here in Brazil, we don't have a adequate, we don't have any turbine or like a large turbine that could do experiments, that could gather data and could do real research, like not real research, but still improve our research with big data, let's say. Okay, so I think that's this is a point that I put on my workshop for discussion, And I think that this is a very important thing, because neither Victor or I believe others can get to your data. You have a turbine at your disposal, at least, I believe. So I think that this is a topic that I wanted to discuss with people. Infrastructure or research and development infrastructure in Brazil.
Yeah. That's a really, really good point. The one that I have access to is a very small one. It's just a 6 kilowatt one. It's not. I mean, it's not tiny, but it's still 20 meters tall, and it has pitch control and stuff, so you can still do stuff on it. But I don't really have access to a large scale wind turbine. Maybe I can just quickly tell you, is the European Academy of Wind Energy is an organization of it's European universities, but it is actually open to non-European universities. And one really interesting thing is that they have a committee, a test wind turbine committee, where they have, let's have a look, they have a map of the test wind turbines that are available within the committee. So you can see that most of them are in Europe. So there's one in Chalmers in Sweden, for example. There's a couple of members. So this is the Canadian Wind Energy Institute, that they've got some operating wind farms, and that's NREL. I know there's also one in Minnesota. I haven't seen this one before. There's also one here in China. And so we're really coordinating, like sharing data from those wind turbines at the moment. It's actually one thing that I'm doing as part of the We Do Wind project, is that I'm currently planning a space where all these people with these wind turbines who are willing to share some of their data, we're gonna make a community of people sharing all this data. And so you might be just interested in joining that and talking to the people and using the data. So that's one thing. And then, well, the other thing is that you might be interested in becoming a member of this organization. But then the other thing about Brazil, like building or creating a research turbine, is I can't really tell you anything about that. Like I think you should try to. I think Brazil should definitely try to do that. But how to do that? Does anyone else have any ideas or inputs about how you'd actually go about doing that? Do you have a large research organization who might be responsible for things like that, or a funding body who might fund something like that?
Well, actually, the Brazilian Energy Wind Association, they also have a part of the directory that they talk about R&D aspects.
But it's still you see,
But more related to the industry.
Yeah, industry is more interested in operating and making money in Brazil. I think that this is a big difference between Brazil and Europe and maybe United States, because it's very difficult to make a contact inside a industry and start doing research with them. Brazil, you know that there's this plan from ANEEL. It's a Brazilian agency of energy that it forces I don't know the rules exactly, but they force them to invest something in research and development. But for me, for example, it's not that easy to get one grant for that. And what is happening in Brazil is that, for example, I don't see, I don't know if people here could help me. For example, there are not many, these grants are not for wind energy so far.
So a grants are available, okay.
Yeah, it's not for wind energy development so far. Do you know something about that? Okay, who got a grant from ANEEL?
Look,
we know Petrobras is funding some development projects, but Petrobras is Petrobras, right? one company.
Yes, but the
Many
problem
others.
is not, it's not the NL. The problem is the companies that want the money does not come from NL. The money comes from the distribution, the energy companies, and
Yeah, but they,
not of the manufacturers, not of the NL. It's from the energy companies, and always the energy companies are just interested in to solve problems and not doing research for the future. It's just
yes,
the problems of that's it's happening, and this is a
action
big
then
problem.
now, right? It's
Yes.
not developed.
Yes.
Yeah, Ingrid, you wanted to?
Yes. I wanted to share a little bit about my experience because when I did my internship, I did my internship in FINEP, the Brazilian Innovation Agency, and we kind of have had a consensus because yes, like the companies, they do research, they fund research, but the thing is sometimes the research that the university they want to do, because it's not like that interesting for the industry, it's like more basic, and sometimes the research that the companies they need is more, I don't know, like TRL4 to TRL8. So this sometimes was a problem. And when I was doing my undergraduation in my university, I remember that there was also like a discussion saying, "Oh, we're not going to sometimes, yes, we want to make projects with the industry, but sometimes we also want the control of those projects." So it was a little bit tricky situation, like it was sometimes a dispute of power. And this is a thing that sometimes I think, like here in Europe, the universities sometimes they are not like that rich, but actually you have a better relationship between industry and the companies. This is my vision of
Industry
the
and academy.
subject.
I think you mean industry and academy.
Yes, exactly, because there are also like researchers in the industry. But this is the thing. You need to have like a common goal. And sometimes the researchers in the university, we already, let's say, have some ego fights in the university. So imagine that when the ego comes in the whole field.
Adrienne, you wanted to say something?
Hi, and a very nice discussion here. I want to point that we may have to organize ourselves here in Brazil, research groups, to work more together. It will be nice if we can share our data and with people from Europe. I was talking about shared data with Professor Alessandro Crossi from Milano, and he taught me a way to do this. May if we have some type of agree with European Wind Energy Academy, the where that Sarah showed us there, just some slides early. And maybe we can do some time, make some time of accord. I don't know. I don't remember the word now. Excuse me. But maybe we may work together to share more data. And another point is that in Brazil now we are some people discussing possibles about a pilot offshore wind energy installation, something like a wind turbine, offshore wind turbine, just for research and data acquisition. Then we may have to talk about this, people from Brazil, what data we need. We want to have about if some project like that will happen here, really happen. Yeah, that's the question. Then may we, a lot of people from Brazil here, we may discuss what we need from this type of project, what data we need. Different from data we will have if we work with people from Europe. They have another type of climate, yes, a winter, different winds, and some data we just will have if we work here in Brazil. We develop a project like that here in Brazil together as a net.
Yeah.
Yes.
Yeah, like I'm making notes on this as you say. I think that's a really good point. Did you, Victor and Carlos have both got their hands up. I think Victor was first.
Yeah, Victor was there before.
Sorry. Ingrid said that in Brazil, the universities are doing basic research, and because of that, the companies are not interested. But I think it's exactly the contrary. The Brazilian is doing the academy is doing researches that it's much more complex that the companies are interested, and this is a problem. Of course, this is a problem, and sometimes I see that the companies contact me to do research together, and after we see that they are not interested in research and real research. They are interested in consultants and to solve problems. And so how I will solve a problem, how I do a research if the target time is 6 months. This is not research. And then we have, of course, I am not saying that the problems is of the companies. I think the problems is of both sides, companies and also the university. The university, the bureaucracy in the university is huge, and this contact, we have this contact, but sometimes, and most of the times, this don't does not go ahead. I have one project prepared, for example, for CPFL. That's a good a big company, energy company here in Brazil. They are interested in fails of wind systems, and because the turbines are become old, and so the phase comes, and they don't know what to do. They just want to to say what we were gonna do. We will just switch the parts. It's not like that, but we try. Yeah, this is very different. Europe, I have done my PhD and also my postdoctorate in Europe, in Germany, and France, and we see that the vision is completely different, not just for of the companies, but also of the universities, and we have to create this mind here also. And I see that I see a good possibility here. With sometimes I see that okay, I am work just with the electrical part, and I have no that data of real turbines. Because I work just with the electrical parts. I have no I don't have a turbine, but if we can discuss, we can arrange, for example, to have maybe a turbine with data. If we have lots of university, and I think that's possible to get money to buy a commercial system and work with this, and have a platform here in Brazil, as Sarah said, a platform that everyone has the access to the data. This is a very good idea. One person to get money for this is complicated, but if we have several people involved, several universities and companies, that I think it's possible.
Yeah. Okay. I'm just aware of the time a little bit, and that we're focusing very much on this one topic of getting a research wind turbine. Carlos, did you want to say something about that topic, and then maybe we should move on to a different topic, because some other topics have come in on the chat now as well.
Yeah, just quick. I think that Victor told exactly what happens. I think that's a culture problem in Brazil. I was a consultant, and now I'm a professor. As a consultant, people would call me. Next day, I would take a plane. I would go to a meeting and start working in one day, and I got my money back. I got paid in 1 month. Academy in Brazil doesn't work like that. So I did both things already, and I think that a company in Brazil doesn't. For example, they don't have PhDs working in companies. If you're a PhD, you want to work in a company in Brazil, okay, maybe not. But just to reassure what Victor was saying, and I do believe that one thing that about using data from other people, that's good. I found lots of data, and I will pass them for my students. For example, I am beginning this, I'm still relatively new in this field. One problem is that, for example, if you want to set up our tests, one specific test, we cannot do that right now. It's a long time frame for example, investigate something new. We need to rely on data people that already there and already have and already done the test. So if we want to investigate something new, a new sensor, for example, that's the difficult. So just to again reinforce the question of having our own test facility. That's it.
Just maybe to add to that from my European perspective and experience, the relationship between industry and academia is also a big issue in Europe. It might be better than in Brazil, and data sharing and a collaborative mindset is also a massive problem. But one thing that people do, the things that come to mind, I think focusing on student projects and internships is one of the most successful ways of closing the gap between academia and industry, because quite often then the students, they might work in a company and then they take their knowledge back into the university, and then maybe they go and work for the company later. That's definitely one thing that we do a lot in Europe. And then I think somehow the funding programs funders have got to realize. I mean, in Switzerland, we have this really good, well, it's got advantages and disadvantages, but a project called, a funder called InnoSwiss, and they fund collaborations between industry and academia. And because they do that, there's then loads of collaboration. But I don't know how to influence funding bodies. I mean, if you have a massive group of people and you approach the funding bodies and you say, we need this, there must be a way that you can somehow do that, but I'm not exactly sure how. Okay. Actually, what I wanted to do in this first part was that each of the lecturers sort of say one or a couple of their challenges, sort of as without going into a discussion, just saying what they think the main challenges are, and then going into small groups and discussing them in more detail. Can we continue with this? So I've written, Cesar, I saw that you've written some things down. I'm going to just take them and put them into one of the,
I have to leave in some minutes, and so maybe
okay.
I just want to do a closure of my parts. Can I do?
Yes. Yeah. You can go first. Then you don't just a couple of minutes. Just maybe say from your perspective what you think the main challenges are, and I'll just make notes on that. And then if you go away later, it doesn't matter. Just I'll make notes. So what do you think? Like, what are your main challenges?
Yes, I will share my screen here. I think I have already said my perspective of companies and university. We see here in Brazil map one where we can find the manufacturers. And so when you talk about manufacturers, we are talking about blades, we are doing electrical parts and then everything. Here we have the capacity of this. And the main players are European and world players are here in Brazil, but not yet the Chinese companies. And so we have manufacturers, but the key is this. We have manufacturers, but we have no national technology. Yes, we have one company, VEG, that's investing in this, but it's kind of we use the international technologies, and it's quite common to see turbines and wind conversion systems having a lot of problems here in Brazil because they are not prepared to be installed in Brazil. The wind of Brazil, the salinity of Brazil, the humidity and everything, and this we need to invest in human resources. We don't have we have PG, we have a lot of people work with this, but I think we need to develop human resources to work in the wind industry. Another problem that we have in Brazil, it's not just to build wind farms. We are just building wind farms, but also we have a problem of the grid. The Brazilian, we have a power system that's interconnected, is one of the strongest in the world, and it's very good. But still, we have problems with the power grid. It's not uncommon to have wind farms that are constructed and they stay without production because they cannot be connected to the grid. This is a problem here in Brazil, and this cannot happen. This is something imaginable to have. And so one perspective is to look to the grid side. We have lots of problems of the grid side. And my last question, this is a question that I do for me always, is the moment to go offshore installations. And so I'm not sure that our onshore market has lot of problems. We have lots of problems with grids. Inside the onshore, I will take a huge amounts of energy to be connected in some parts. I don't know where, but the problems will become bigger and bigger and bigger, and without solving the old problems. And so it's just a question that I have no I just to the question. I have no answer for this, but I leave for everyone the question: is the moment to go offshore?
All right, great, thank you. I've made notes of those points. We'll make sure to discuss those in the groups. Are you leaving right now or
yes,
later?
Unfortunately I have to leave. I have some classes at afternoon. Right. So, but thank you everyone, and you have my contacts, and I am available. Night.
For your lectures as well and for your inputs, very, very much appreciated, and I hope we can continue to work together. So have a good day and see you later. Bye. Okay, so Yoshi, do you want to, you kind of already mentioned your challenges. Can you just recap very briefly so that I can make some notes on my screen about the challenges the top challenges that you that you think?
The challenge, I think, my challenge, in my mind was more scientific, more research than general.
Which is fine. Yeah.
General issues
Yeah.
that raised here, but the research that I challenge focus on my research, but is open to discussion, of course, is related to how we can extrapolate and estimate the wind profile above the surface layer, how to improve the simulations that are couple integrate with ocean conditions related to the sea surface temperature and the waves. That's a big challenge because usually the background for simulations, they have experience with topography, complex terrain, but now we have a dynamic topographic and the interaction with the surface that's quite different. That are very few knowledge about these improvements that we need to do. So that's these two issues that I started for challenge. Of course, the third one that I mentioned was measurements, to how we can do many measurements campaign in offshore sites. There are, of course, many solutions about the floating platforms, how to correct these. So there are many issues about these two, about campaign and instrumentations, local sites instrumentations.
Yeah. Okay. Okay. Good. I've written those down. Then, Carlos, do you want to sort of summarize what your main challenges would be?
Oh, my main challenge, a technical challenge, would be the integration of sensors and diagnosis systems. Okay, so or identification systems, because we have lots of research on specific sensors and strategies to deal with, for example, accelerometers or strain gauges or whatever, or temperature. But then when everything is working together, how do you deal with that in a real wind turbine? So lots of information come at once. Okay, I think this is the.
I've already got the answer to that. No, I'm only half being serious. No, I'm working with a company in Switzerland who actually tried to answer that question. So they're developing a platform where they can, it's not to develop the hardware, it's to develop the software. So like once you have some data coming in from some sensor or from lots of sensors, like how do you actually convert that in an efficient, easy way to diagnostics and then to decisions? And it's quite difficult to do that independent of hardware, right? Usually most of the solutions, you have a hardware and you have a software and they go together, but to have some software which is independent of whatever measurements you're making is quite a difficult thing, and that's kind of what they're working on. So maybe
great.
Yeah,
Perhaps I could. Yeah, I will start following. I opened this page already here, and that's very good. Like it's a real problem, right?
Actually, there's something I want to tell you about related to that, which has just come to mind. This Inner Swiss funding agency, which I told you about, actually has a specific Brazil call, and I haven't. I talked to Yoshi about it once before. I just need to find it. Sorry, that's while I'm talking, it's not that easy. Maybe it's this one. But the trouble is, it requires, you need a university and you need a company in Switzerland, and the funding goes to the university, but the results go to the company. And the difficulty is that when you find a partner in Brazil, you have to do it according to the requirements of this EMBRA P. And the reason why Yoshi and I never applied for it is because we had to find a configuration where the Swiss company wants to enter the Brazilian market with their part of the project, but the Brazilian companies wants to try to enter the Swiss market with their product, and they're kind of exchanging information, and then they're selling complementary things. So they shouldn't be competing with each other. And so it ended up being a really difficult configuration. But in the meantime, I have this project Aerosense, which I told you about. It's we've got this hardware, this blade pressure measurement, and we want to expand that beyond wind energy. We want to like measure any structure that's in the field. And there could maybe be a complementary thing that we can find related to that.
We can apply to bridges. We can apply to towers, transmission lines, for example.
Yes, yeah. But it would have to be like somebody in Brazil would have to. I mean, I can't remember what the requirements were now of this organization. But do you remember, Yoshi, what the requirements were from your side? Did you have to have a company as well?
Yes, it needs a Brazilian company that also give support for this as well. We did not find any company that matched to the company in Swiss that can have this exchange.
Yeah, but so maybe it doesn't have to just be Carlos, but especially Carlos. If you maybe have a read of that, I just put it in the chat. If anyone feels like that could be something in particular related to this company, we can talk about that another time.
Yeah, I found, and I already shared with people from GEPOC, for example, that they are more experienced than me, and we discussed that. Okay, that's great. Thank you for this information. I can talk with Yoshi later.
Yeah. Okay. Cool. All right. And then Ingrid, you started off this good conversation about a research wind turbine. Do you have I guess you have lots of other challenges to the list.
I have, let's say, things more in high level. I believe that the main, let's say, technical aspects everybody pointed. Actually, there's one that, I think it will be like the first one that I will highlight. It's kind of related to this one. One of the main challenges that I see is that in Brazil, we don't have a maritime special planning. And this is a bottleneck for not only offshore wind, but for everything you want to develop in the sea. And with that, I would consider the data. It's very hard to find data, like we were talking about turbine, but data, even like the wind data, sometimes you don't have like that very mapped. You only have like the data from the ERA, I believe, or NOAA satellites, but you don't have like actual measured data. Another thing that I think it's kind of interesting. It's that the energy mix in Brazil, 1/3 of the energy mix is it's spent with the consumptions is for transports. So I think Victor was highlighting the issues for transmission, and I totally agree with him. But here in Europe, it's really common for people to use like the train system. We also have like some targets of electrical cars, but at least here in Germany, everybody loves to use the public transportation systems. And this could also be like, let's say, a way of putting the energy in the system, because I believe that right now the way that the energy consumption works in Brazil, yes, it will be a really hard challenge to insert all of the energy of offshore wind farms if you don't have like a proper storage or a proper consumption way. The other challenge would be that in Brazil, unfortunately, you have like an energy planning, but you don't have established long time goals as we have like here in Europe. Like, that by 2030, 2040, 2050, how much the country wants to have as offshore wind as of renewables. And in Brazil, they always say, "Oh, the market will do that." And I
Oh,
think if you don't
really?
have, yes, yes,
Wow.
basically this is the thing that they say. Even in the US, is actually the states, but they believe that because like Europe kind of like started to say oil is bad, so we want to change to switch to renewables. They think like the idea in Brazil is they are already doing this in Europe. They are already convinced it's bad, so they will eventually implement this here. And but here in Europe, we also have subsidies for these long-term goals that in Brazil we used to have in the beginning of the renewables, as I mentioned in my lecture on Monday. But right now for offshore wind, yes, there are some discussions that maybe for like leasing the area, the amount paid would be less. It will be like vary on the energy production of the area or the price, as they say, but you won't have subsidies. And these, let's say, might not lead the companies to develop, at least in the free market, which usually for renewables is the market that the renewables they sell most of the energies.
This is
And of course,
crazy.
yes, and of course I would point the fourth one, the regulation, because like the regulation is not ready yet. So unfortunately, like sometimes the projects they want to start developing, but they need to develop until certain point because they don't have like the mechanisms to go ahead. And also, there was a fifth one that I wanted to mention is the players of the market, because if you have a look on the players, it's a very interesting situation. They are like either oil and gas players or they are already in the renewables. But the thing is, the ones that are already in renewables, some of them have already developed some projects in Asia and in Europe, but they don't have the data from Brazil probably. And the oil and gas, they have probably like they are starting now or they have never developed a real offshore wind farm. So this is also a huge issue. Like in Brazil, you don't have Vattenfall, you don't have Ørsted. I think ENBW also developed some projects here in Germany, but they are also not in Brazil.
Mm. Yeah, it's really good. This whole thing about energy system planning and targets and political incentives and stuff, it's really interesting because I was just showing on my screen while you were talking. In Switzerland, they do that quite a lot. I mean, I don't really know how it compares to other countries, but like the EU does it a lot, and then Switzerland has got their own strategy, and they have they have these perspectives where they think about what they develop an energy system model for the whole country, and they think about what would happen if we did this and what would happen. And, there's big funded research projects in the whole of Switzerland, which are actually, going into the details and working these things out. And it surprises me quite a lot, the lack of that. I mean, it must be quite difficult in such a big country, I suppose, but that's definitely if that really doesn't exist, there's definitely a problem there. But at least you've got a new government now.
Yes, and a government that really wants to support this sustainable development. So but I don't know if actually it will be possible to develop long-term policies, because unfortunately the thing is I had the opportunity to do my internship in a public companies when like the time for a president changes, sometimes all of the policies they also change it. This is a very high issue
in
for
the US
public companies and the government.
I mean, in the US, it's absolutely crazy, isn't it? In the US, because they're so polarized, they just go back and forward the whole time and don't get anything done.
Same.
Actually, the Swiss system is, I don't know how many of you know about the Swiss political system, but it's they have this Bundesrat, which is a group of 7 people who make all the decisions, and they're represented by the top 3 parties, and they have to have an agreed opinion on everything, which means that it's much more stable. You know, you don't get these crazy up and down, but the difficulty is that it takes ages to make any decisions. So it's impossible to install wind turbines because they always get blocked. Like women's rights are miles behind any other country. So I mean, it has disadvantages and advantages. Anyway, let's go into the next part. So thank you very much for all your inputs. I've on my screen in this Jamboard, I've shared the Jamboard link with you somewhere. Sorry, I shared quite a few other things. I did share the Jamboard link, but I can just quickly share it again so to make it easier for you to find. So the idea would be the following. I will split you up into groups, and on the first page, don't touch the first page, because the first page is just what the lecturers just said. For each group, so depending on what group you go into, what you can think about is which challenges are missing and how can you maybe contribute to addressing any of the challenges. And the 2 that Cesar already put, I've just copied into here. Just a little bit about using Jamboard in case you're not familiar.
The 2 blogs are the same thing. Sarah, the 2 blogs are the same thing. I think that decision support 2 is the best.
Okay. Right, they can go together. Yeah, okay, they can go together. That's fine. So depending on what group you're in, just go to the page. I just need to think about how many groups we want. There's like 20, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 people. So if we go into 5 groups, I guess, that'll be okay. So I'll make 5 pages here. So I didn't know in advance how many groups there are going to be. And so just use the page associated with your group number to make notes. And the way you can make notes in this Jamboard, if you're not familiar, is the best thing is to just copy and paste these. You just press Control-C and Control-V to copy and paste these Post-it notes. And I'm just putting the questions in. So leave those questions in place, but you can add, let's say you can add blue ones. So you can copy and paste, you can write text, you can change the color if you want. And you can also add new Post-its here.